Let us indulge in a fantasy. Let us imagine, for a moment, that we have solved everything. Imagine a future, perhaps 1,000 years from now, where humanity has transcended the clumsy chemical rockets of the 21st century. We have bypassed the tyranny of the rocket equation, which dictates that to carry more fuel, you need yet more fuel to lift it. We have unlocked the secrets of fusion, or perhaps we harness the annihilation of antimatter. We have built a spacecraft that is, by every definition, perfect. It has infinite energy. It has shielding that can withstand the fiercest solar storms. It has artificial gravity to protect our bones and medical bays that can repair our cells. We look at this gleaming vessel and think, finally, now, the stars are ours. We believe that technology is the master key, and the universe is merely a locked door waiting to be opened. But this is the greatest lie we tell ourselves. The reality is far more sobering and far more brutal. Because even if you build a perfect machine, you cannot build a perfect universe. And you certainly cannot redesign the fragile biological creatures that sit inside the cockpit. The moment we try to leave our cosmic neighborhood, we discover that the true enemy isn't a lack of engineering. It is the fundamental fabric of reality itself. And let's embark on this hypothetical journey. We start our engines. Our destination is Proxima Centauri, our nearest stellar neighbor. It is 4 light-years away. To our ancestors, who crawled at the snail's pace of 61,000 kilometers per hour with Voyager 1, this journey would have taken over 73,000 years. But we have our perfect ship. We want to get there in a human lifetime. We want to get there in 5 years. To do that, we must travel at roughly 90% of the speed of light, and this is where the universe begins to set its traps. And, as we accelerate towards this unimaginable speed, the view outside the window changes. The stars in front of us don't just rush past like in the movies, they shift. Due to the Doppler effect, the visible light from the stars ahead turns blue, then violet, and finally shifts into invisible, high-energy ultraviolet and X-rays. The harmless cosmic microwave background, the leftover heat from the Big Bang that permeates all of space, is blue shifted into a blinding beam of gamma radiation. Simply by moving fast, you have turned the vacuum of space into a death ray. Our perfect ship must now withstand a bombardment of radiation millions of times more intense than anything found near a star. But radiation is the least of our worries. We tend to think of deep space as empty, a vast void of nothingness. But space is not truly empty. It is filled with dust, gas, and stray atoms. When you are moving at 270,000 kilometers per second, definitions change. A single hydrogen atom, usually harmless, now strikes the hull of your ship with the energy of a high-velocity particle beam. And if you hit something tangible, a speck of dust, a micrometeorite the size of a grain of sand, at these relativistic speeds, kinetic energy is immense. A collision with a grain of sand wouldn't just scratch the paint. It would release the energy of a tactical nuclear weapon. Space becomes a minefield where the mines are microscopic and everywhere. We know from our experiences in low Earth orbit that even at slow speeds, a paint fleck can crack a window. At 90% light speed, the interstellar medium behaves less like a vacuum and more like a solid wall of concrete. Our perfect ship would need shielding kilometers thick, or energy fields that require the output of a small star just to deflect the dust. But let us be optimistic. Let us assume our shielding holds, but the ship survives. Now we must look at the cargo, the human crew. This is where the dream of interstellar travel crashes hardest against the rocks of reality. We are biological entities, evolved over millions of years to survive in a very specific, very gentle environment, the surface of Earth. We are not built for the stars. We are built for a gravity of 1 g, an atmospheric pressure of 1 bar, and a magnetic field that cuddles us from the horrors of the cosmos. The first problem is acceleration. To reach 90% of the speed of light, you cannot just push a button and be there. The human body is a soft sack of fluids and organs. If you accelerate too fast, the G-force will pool your blood in your feet, starve your brain of oxygen, and eventually crush your organs against your spine. To keep the human crew alive, we can only accelerate at a comfortable 1 g, the same force we feel standing on Earth. It sounds reasonable. But do the math. To reach near light speed at 1 g, you need to accelerate continuously for nearly a year. That is a year of pushing the engines to their limit, just to reach cruising speed. And during this journey, what happens to the body? Even with artificial gravity, the environment of a spaceship is a biological cage. We have seen what happens to astronauts on the International Space Station, who are mere minutes away from Earth. Their bodies begin to dismantle themselves. Bones are the first casualty. In the absence of true Earth-like stress, the body decides that a strong skeleton is a waste of energy. It begins to dissolve your bones, releasing calcium into the bloodstream. Astronauts lose 1% to 3% of their bone mass every single month on a long interstellar voyage. Even with exercise, a crew member could arrive at Proxima Centauri with the skeleton of a 90-year-old with severe osteoporosis. Imagine arriving at a new world, ready to explore, only to shatter your femur simply by stepping out of the airlock. Then there are the fluids. On Earth, gravity pulls fluids down. In space, they rise. The face becomes puffy, the sinuses clog, and pressure builds up inside the skull. This pressure pushes against the back of the eyeballs, flattening them and permanently damaging vision. We are talking about a crew that might go blind, simply because they left their home planet. And the heart, our most vital muscle, grows lazy. It shrinks. It loses up to 20% of its mass because it no longer has to pump blood upwards against gravity. It becomes the heart of a different creature, one not meant to walk on a planet. But the most insidious enemy is one we cannot see, feel, or touch until it is too late. Radiation. We mentioned the radiation from the ship's speed, but cosmic rays are everywhere. Galactic cosmic rays are high-energy particles that tear through DNA like microscopic bullets. On Earth, we are protected. There, in deep space, there is no place to hide. Current data tells us that a simple round trip to Mars, just a few years, would expose an astronaut to over 1,000 millisieverts of radiation that is equivalent to 12,000 chest X-rays. It ravages the bone marrow, weakens the immune system, and skyrockets the risk of cancer. Now extend that to an interstellar mission. Shielding is difficult, lead is heavy, and water layers need to be meters thick. Even inside our perfect ship, secondary radiation, created when cosmic rays hit the shield itself, can be just as deadly. The crew that arrives at Proxima Centauri would not be the healthy, heroic explorers we see in science fiction. They would be biologically compromised, their DNA riddled with errors, their bones brittle, their eyes failing, and their cognitive functions declined due to brain damage from radiation. They would be a broken species, barely clinging to life in a metal can. And yet, there is a barrier even more profound than biology. A barrier that technology cannot engineer away because it is woven into the very concept of existence: time. Let us assume we solve the biology. We upload our minds into machines, or we cure cancer, or we freeze our bodies. We are now traveling at 99.9% of the speed of light. We are conquering the distance. But as Einstein taught us, space and time are ed. The faster you move through space, the slower you move through time. This is not a hallucination. It is physics. If you travel to a star 500 light-years away at 99.99%, the speed of light, for you, the journey might only take a few years. You will eat a few thousand meals, read a few books, and you will arrive. You will feel young, but outside the hull of your ship, the universe has aged. While you spent 10 years on your ship, 1,000 years have passed on Earth. This is the great tragedy of interstellar travel that no technology can fix. To explore the universe, you must divorce yourself from your own timeline. You become a time traveler, but only in one direction, into the future. Imagine the horror of this success. You reach the galactic center. You see wonders no human eye has ever seen. You have achieved the impossible. But when you turn your perfect ship around and head home, the silence on the radio is absolute. You return to Earth, but the Earth you knew is gone. Your children died centuries ago. Your nations have crumbled. The language has changed, but perhaps humanity itself has evolved or extinguished. You are not a hero returning home. You are a ghost haunting a graveyard. The distance between stars is not just measured in kilometers, it is measured in relationships, in history, and in shared existence. The universe forces us to make a choice. Stay home and remain connected to humanity, or leave and become an alien to your own kind. The faster we go, the lonelier we become. So, we are trapped. Slow ships mean we die of old age before we reach the stars. Fast ships mean the civilization we left behind dies before we return. But even if we accept this isolation, Even if we accept that to leave Earth is to say goodbye to everyone we ever loved forever, there is a larger, darker realization waiting for us. We have spoken about the barriers of speed, of biology, and of time, but we haven't talked about the scale, the sheer, mind-breaking scale of the container we are trying to cross. We look at the night sky and see a static tapestry of stars. It looks peaceful, it looks reachable. But this is a trick of perspective. The universe is not a static place. It is expanding, and it is expanding in a way that turns our perfect technology into a cruel joke. Because even if we have a ship that can fly forever, and even if we are immortal, there are places we can never reach. In fact, most of the universe is already lost to us. As we look deeper into the void, we begin to realize that we are not just fighting distance, we are fighting the expansion of space itself. And this is a race we are mathematically destined to lose. We are standing on the bridge of our perfect starship, traveling at near light speed, and yet we are losing ground. To understand why, we must look at the largest scale of reality. We often picture the universe as a vast static room filled with furniture, the galaxies. We imagine that if we just travel long enough and fast enough, we can visit every corner of this room. But the universe is not a room, which is an explosion that never stopped. The cosmos is expanding. This is not new knowledge. We have known this for a century, but the implications for our interstellar ambition are devastating. As light travels towards us from distant galaxies, space itself stretches, carrying those objects away from us. This creates a terrifying boundary known as the cosmic event horizon. Imagine a runner on a treadmill. The runner is our spaceship, moving at the absolute speed limit of the universe. The treadmill is space itself, and the cation, for nearby objects, the treadmill is slow, and we can make progress. But the further away you look, the faster the treadmill moves. At a certain distance, space is expanding faster than the speed of light. This means there are galaxies, billions of them, that are receding from us faster than our ship can ever fly. Even if we could travel at the speed of light, we would never catch them. The light they emit today will never reach us. They are disconnected from our reality forever. We currently believe the observable universe is about 93 billion light-years in diameter, but this number is deceptive. It is a historical record, not a map of reachable destinations. Because of this expansion, we calculate that 94% of the galaxies we can currently see are already beyond our reach. We can see them only because we are seeing their ancient light, emitted billions of years ago when they were closer. But in the now, they have crossed the horizon. They are gone. We are not citizens of a vast universe. We are inhabitants of a shrinking island. Gravity binds our own cluster of galaxies, the local group, containing the Milky Way and Andromeda, together. We will merge with them eventually. But everything else? Every other cluster? They are rushing away. And, in the distant future, they will fade from view entirely. The sky will darken. An astronomer born in that future will look up and see only our own galaxy, believing the universe ends at its edge. They will never know that other galaxies ever existed. So, our perfect technology is trapped in a cosmic cage. We can explore our local neighborhood. Yes, we might even reach Andromeda, 2.5 million light-years away, but we can never leave. We are imprisoned by the expansion of the very space we seek to conquer. But let us assume we are content with this cage. The local group is still enormous. It contains trillions of stars. Is that not enough? This brings us to the next layer of the nightmare, the psychological horror of the void. We must remember that the human brain is a product of evolution on the African savanna. It developed to estimate distances to a water source, a tree, or a predator. Our ancestors needed mental tools to understand the next 100 meters, not billions of light years. When we deal with the scale of a city, our intuition begins to fail. With the scale of the cosmos, our brain simply gives up. But on Earth, we are never truly alone. Even in the middle of the ocean, there is a sky, there is wind, there is the curvature of the planet, there is a down and an up. In the deep void between stars, and especially between galaxies, these concepts dissolve. Imagine the view from your ship halfway to Andromeda. You look out of the window. There is no sun. There are no planets. There is no nebula, painting the sky with color. There is only absolute, crushing blackness. The Milky Way is a smudge behind you. Andromeda is a smudge ahead. For years, decades, perhaps centuries, the view does not change. This is a sensory deprivation tank on a galactic scale. The isolation is total. A simple question sent to Earth would take 2.5 million years to arrive. A conversation is impossible. You are severed from the human race, not just by distance, but by an unbridgeable silence. Psychologists doubt that the human mind can withstand this. We are social creatures. We need feedback. We need the cycle of day and night. The first is, in the void, there is no time. There is only the hum of the ships, reactor, and the endless dark. Even with a crew, the knowledge that you are a microscopic speck in an infinite nothingness would act as a slow poison to the psyche. The emptiness outside begins to seep inside, and this leads us to the ultimate enemy. The one that makes even the expansion of the universe seem trivial. Entropy. Let us play the long game. Let us imagine we become machines. We upload our consciousness into computers. We no longer care about time, or biology, or psychology. We can sleep for 1,000,000 years and wake up at the destination. We have defeated death, or so we think. But the universe itself has a lifespan. It is not a permanent stage. It is a dying fire. Stars are giant engines that convert hydrogen into helium and heavier elements, but their fuel is finite. Our sun will die in about 5 billion years. Larger stars die much faster. The cooler red dwarfs, like Proxima Centauri, burn slowly and can live for trillions of years, but eventually, even they will flicker out. Star formation is already slowing down. The universe has passed its peak fertility. Day by day, year by year, the lights are going out. If our civilization survives for eons, hopping from star to star, we will eventually face an era where there are no new stars being born. We will huddle around the last dying embers of white dwarfs and black holes, harvesting the last scraps of energy to keep our machine minds running. But eventually, even black holes evaporate. This is the heat death of the universe. A state where all energy is evenly distributed, where no work can be done, where nothing can ever happen again. It turns out that our quest for a perfect technology was merely a struggle to build a more comfortable lifeboat on a sinking ship. We can extend the journey. We can make the ride smoother, but we cannot stop the ship from going down. This realization that we are trapped by speed, broken by biology, isolated by expansion, and doomed by entropy, sounds profoundly depressing. It seems to render all human endeavor meaningless. Why reach for the stars if the stars are running away? Why build a spaceship if we are just soft bags of water destined to die? But this is where the perspective shifts. In the Somme, when you look at the sheer hostility of the universe, when you realize that 99.9999% of the cosmos is a lethal, radioactive, freezing vacuum designed to kill us, you begin to see something else. You begin to see how miraculous it is that we are here at all. We live on a pale blue dot, as Carl Sagan called it, a speck of dust suspended in a sunbeam. This planet has a magnetic field to shield us from the radiation that fills the rest of space. It has an atmosphere that gives us pressure and breath. It has gravity that strengthens our bones rather than crushing them. It has a moon that stabilizes our axis. The fact that we cannot easily leave forces us to look at what we have with new eyes. We are not trapped. We are sheltered. The barriers of the universe, the vast distances, the speed of light, act as a quarantine, yes, but also as a reminder that we belong here. We often talk about becoming a multi-planetary species, as if Earth is disposable, as if we can trash this home because there is a backup waiting on Mars or Proxima Centauri b. But as we have seen, Mars is a radioactive desert that requires us to live in tunnels. That, Proxima Centauri b, is bombarded by stellar flares that would strip away our atmosphere. There is no planet B, not really. Not one that can replace the paradise we evolved for. And yet, there is a triumph in our situation. We mentioned earlier that our brains are designed for the African savanna, for distances of a few hundred meters. And yet, this ape brain, evolved to throw rocks and hunt gazelles, has managed to calculate the age of the universe. We have measured the distance to galaxies we will never touch. We have deduced the life cycle of stars we will never visit, even if we cannot travel there physically. Our intellect has crossed the void. Every telescope is a time machine, allowing us to witness the birth of the cosmos. We can explore the universe without moving a muscle. We can understand it. Do not feel sad that they are out of reach. Do not despair that you will never walk on a planet in the Andromeda galaxy. Instead, feel the ground beneath your feet. Take a breath of the air that, unlike the air on Mars, is free and abundant. Feel the gravity that holds you in a loving embrace, not a crushing grip. We are travelers who have already arrived at the best possible destination. The universe is vast, cold, and indifferent. But here, on this tiny, fragile rock, for a brief, flickering moment in eternity, we are warm, we are together, and we are alive. And perhaps that is enough.